So, welcome back to Made Easy Academia. We are still under dimension analysis, unit measurement and dimension. As I told you yesterday, after we check how to use dimension to check if a quantity is right, if it is equal, if what we have at the right hand side equal to what we have at the left hand side. So now the next one now is a equation involving dimension analysis. In these equations, meaning how are we going to be finding the values? Maybe we ask to find the value of x, or maybe we ask to find the value of y, or maybe we ask to find the value of w, or whatsoever. So we can make use of this equation of indices, linking it together with dimensional analysis. Equation involving dimensional analysis. In this area, as I mentioned, we'll be looking for unknown values. It might be x, it might be y. It depends on what we are looking for. Let's look at these some past questions that we have here. They said, suppose we are told that the acceleration of a particle moving with uniform speed v in a circle of radius r is proportional to some power say r raised to the power of n and some power and v raised to the power of m. Determine the value of r, determine the value of n and m and write the simplest form of an equation and write the simplest form of an equation for the acceleration. So for the acceleration, so let's look at this problem. It's just a simple questions and straightforward to answer. They said, suppose we are told that the acceleration of a particle moving with uniform speed v in a circle of radius r is proportional to some power, say r raised to the power of n and v raised to the power of m. Then they said we should determine the value of n and m and write the simplest form of an equation for the acceleration. You know, in the previous example, we have already shown on how we can determine the dimension for accelerations as well for radius at the same time for speed, because here the first thing we need to do is to know what it is letters represented here. If they mention a and they say a that they mention here is for accelerations, those are the things that you have to take note of. And in the problem, they say acceleration is we know in the previous video we have already talked about how we can determine the dimension for accelerations, which is known as lt raised to the power of -2. And here too they said the v that they're talking about here, it means speed. And I've already shown you how to determine the dimension for speed, which is nothing but lt raised to the power of -1 as well. And they mentioned radius. They said how that they're talking about here, it means radius. And if you recall, I told you there are some terms in physics that we normally use. Either they use under the dimension, if they use distance, displacement, radius, amplitude, wavelength, extension, radius. All these terms, they are all the same as length. This is nothing but L. So now they now said acceleration A of a particle is proportional to some power of r raised to power of n and v raised to power of m. It's directly proportional. Now we know that this sign is a sign of proportionality. Like if, for example, if I have A proportional to B, meaning as A is increasing, B2 is also increasing. If I want to change this term, I can say A is equal to KB, where K that we use here simply means constant. So that's what I'm trying to do here now. So since they said A is proportional to R raised to the power of N and V raised to the power of M, meaning I can have this one to be A is equal to K R raised to the power of N and V raised to the power of M. Don't forget, they said A is acceleration. The K that we use here is just a constant. R they call it here, they say is radius. At the same time, the V they use here is simply means uniform speed, as they mentioned from the problem. So since it's just a constant, I can just remove this one and put it later. This can just be written as A is equal to R raised to the power of N and V raised to the power of M. I hope you are following, right? Yeah, good. So now the next thing is we know dimension for accelerations to be LT raised to the power of minus 2. We know dimension for R, that R is nothing but length, which is L, and we know dimension for V as well, that V is LT raised to the power of minus 1. So let's just substitute each of them one after the other. So my A is that is LT raised to the power of minus 2 is equal to our R, which is radius. We have L raised to the power of N. So our V that we have is LT raised to the power of minus 1 or raised to the power of or raised to the power of N. Just a simple substitutions. Our A is acceleration is nothing but LT raised to the power of minus 2. Our R, which is a length, which is radius as is mentioned, but we know that length and radius in this dimension, they have the same dimension here. We have it to be L raised to the power of N. Our V, which is a LT raised to the power of minus 1. So they all have M. That's a raised to the power of M. I hope you are following me, right? Yeah, good. Now, the next thing now, since we know, under the law of indices, if I have x squared, y3, and 5, the one that we have outside there can affect the two power that we have in the bracket. Meaning this 5, we affect 2, at the same time, we also affect 3. So here I can have x raised to the power over 2 times 5, then y raised to the power over 3 times 5. How did I do that? The one that we have outside there, let me write it boldly so that you can see very well. What I'm trying to do here is, what we have outside can affect the two numbers that we have in the bracket, the two powers. Meaning I can have x raised to the power, we can see the first power we have here is 2. It's going to affect the one that we have outside there. That is that we have 2 times 5. Then the second one, 2 as well. That's a 3 times 5. Then here we have x raised to the power of 2 times 5. That's going to be 10. Then y raised to the power of 3 times 5. That's going to be 15. So that means I want to apply the same logic here. So that I will use this m, it will affect the first one. At the same time, we also affect the second one as well. So here we can have LT raised to the power of minus 2 is equal to L raised to the power of N. So now this M that we have here will affect the two base that we have inside the bracket. So the power of this one is 1. So if I open the bracket that we have L raised to the power of 1 times M, and we have 1M. 1M is the same thing as M. Then T raised to the power of minus 1 times M, of course, and we have minus M. So we just use the law of product law here. The M that we have outside affect the two powers that we have inside the bracket. So now, under the law of indices, I've shown you in the previous example that we have what we call addition law, subtraction law, and inverse law. So you can only apply addition law if you see two exponential over the half base together. That, like, if you look at this one, you can see I have L here, I have L here, meaning I can combine them together using the addition law. Since if I have multiplication, it change to plus. The moment I pick one base, then I can sum their powers together. So here, we can have this one to be LT raised to the power of minus 2 is equal to L. This is L, this is L. I take 1. So the power of this one is N, and the power of this one is M. So that means I can have N plus M, then T raised to the power of minus what? Minus M. So what do we do here? I only pick one base and sum their powers together. So now after that, so So now the next thing for us now, so what we have, let me write it here. So what we have is that LT raised to the power of minus 2 is equal to L raised to the power of n plus m and T raised to the power of minus m. So the next thing now is to just equate the two, compare what we have at the right hand side together with the one you have at the left hand side. That is L for L and T for T, meaning L for L at the same time T for T. So what I have here is that is L is equal to L raised to the power of n plus m. Then the second one too as well. T raised to the power of minus 2 is equal to T raised to the power of minus m. Note one thing here. We can only equate base that are the same together. That is, I can only equate L for L at the same time T for T. Meaning we cannot equate L for T. They have to be the same so that we can be able to equate the two together. So now recall, like, if you don't have any power, can you recall the power I told you here? I told you in the previous example. Yeah, so since this doesn't have any power, it means the power is 1 here. You can see the base are the same, meaning they cancel each other. So what we have left here is 1 is equal to n plus m. The same thing applicable to this, the base are the same, cancel each other. The power that we have left here is minus 2 is equal to minus m. You can see in the first expression, we are looking for two unknowns. And in the second expression, we are looking for how many unknown? Just one unknown. So that means this one is very easy for us to solve. The moment the minus cancel minus, I can have my m here to be equal to 2. So that means the value of our m is equivalent to 2. So if I go back here, I can just make a simple substitution. So since my m is 2 now, that means I can have 1 is equal to n plus 2, right? If I collect the like terms, that means I can have this one to be 1 minus 2 is equal to n. So that means our n is equal to minus 1. So meaning n is equal to minus 1 and m is equal to 2. But assuming the problem just says as you find the value of n and m, I have to just stop here. But the problem says write the simplest form of an equation for the acceleration. So since I've gotten my n to be minus 1, I've gotten my m to be 2, I will just go back to the first expression, the first given equation that we have that what we have in the previous equation. This is what we have. Can you see? We have a is equal to k, r raised to the power of n, and v raised to the power of m. I will just make the value, just substitute the value of n and m. So now here I can have, therefore, I can have acceleration to be k, r raised to the power. You can see my n is minus 1. It is minus 1, and our m is 2. I can have this one to be 2. Still I can apply the law of reciprocal here, since what I have here is r raised to the power of minus 1. So this one can just be a is equal to k 1 over r then v squared. If I have law of indices, if I have a raised to the power of minus m is nothing but 1 over a raised to the power of m. So now since I have r raised to the power of minus 1, meaning this is nothing but 1 over r, so this one can just give us a is equal to k 1 times v square. Of course, we are going to have v square over what? Over r. So this is the simplest form of equations for accelerations. And here, our n is minus 1, and at the same time, what we get for m is equal to 2. So let's look at another examples and see how we can approach the problem. Let's check another questions. So in some problem, it depends on how you have the approach. You can have maybe 3 unknowns. It depends on how they bring the question. So if you have 3 unknown as well, just follow the same process and you get your result. So let's look at this problem. Here they said, in this problem here, they said that if a string fixed at 2 ends in an experiment, is displaced it will be seen to vibrate with a velocity with a velocity v and produce a wave that depends on the following. That depend on the following. That depend on the following. Tension F. It depends on the tensions. Tension F of the string. Of the string. The second one is also depend on the length L of the vibration string. And at the same time, it depends on mass m of the string itself. So if V, should now say if V is proportional to F raised to the power of A, L raised to the power of B, and M raised to the power of C, show that V is equal to K root of FL over M. Even without being told, what we are asked to show here is to show that if this expression we hold, show that K is equal to square root of FL over M. So I told you what you need to know is what the teacher letter given there represented. So from the problem here, he said when we see F here, F simply means tension. And if this tension is the same thing as what? As force. Now, so the length, they say L, whenever we see L in this expression, L simply means length. And when we see mass and mass simply means M. So in the previous example, I've told you the dimension for velocity, at the same time, the dimension for F, dimension for L, and at the same time, dimension for M. So what we need to do, just let's firstly bring out all those dimensions of all those values one after the other. I know if we have V is a velocity, as they mentioned, that we know dimension for velocity is LT raised to the power of -1, right? Now, fine. And the dimension force here, which is tension, which is ML T raised to the power of -2. L is L at the same time, M is M. So that means the only thing that we need to change is the velocity at the same time, the force that applied or in the string. So now, if I go to this is sign of homogeneity, right? As I told you earlier, you can just write this one to be F is equal to K, F raised to the power of A, L raised to the power of B, and M raised to the power of C. Don't forget, this case is just a constant, so I can just ignore that one and let me put it there after I go to the value of A, B, and C. So meaning, therefore, this one can be written as V is equal to F raised to the power of A, L raised to the power of B, at the same time, M raised to the power. You see all this grammar? They are just telling you what it is later represented there. What F represented, at the same time, when we have L, at the same time, when we have M, even at the same time when we have M. So after you know what it is later represented, just go back, recall from the previous one that what is the dimension of V, which is velocity, dimension for tension, which is force, at the same time for length, then as well as the mass. So after knowing that, you don't have any issue. Just plug them and find the values one after the other. Now let's continue this. So we have V proportional to F raised to the power of A, L raised to the power of B, and M raised to the power of C. And I told you this sign is just a sign of proportionality. So when you change that one, then we have V is equal to K, F raised to the power of A, L raised to the power of B, and M raised to the power of C. Meaning the K that we put here is just a constant, as I have already showed in the previous example. So if I remove that one, just for me to find the value of A, B, C. And don't forget, in some textbook, they can put this one in form of bracket like this. It's still the same thing. So please don't forget that. You can put it in this way just to demarcate and differentiate between the two values. It's still the same thing. So now, after that, I've known that the V is a velocity. What we have there is a LT raised to the power of -1 is equal to the force is nothing but ML T raised to the power of -2. Then I have A Then I know that L is L itself, L raised to the power of B, and M is M, then M raised to the power of C. So the only thing that will change here is the velocity at the same time and the force. So I've already shown you again what they call the product law, but I will still mention it again. The product law means the one that we have outside here must affect everything that we have in the bracket. Each exponent, Now, like this one now, this one doesn't have any power, and we have mentioned that if it doesn't have any power, it means it has a power of 1, as well as this one also have a power of 1. So now, this A that we have outside here will affect everything that we have inside the bracket. So now, let's just clean this side so that we put it here. So meaning, okay, let me just manage one line here. I can have LT raised to the power of -1 is equal to, now, the A that we have here must affect everything that we have in the bracket. So that means I can have M raised to the power over A times 1, of course, 1A. And 1A is nothing but A. L raised to the power over A times 1 also, and we have A. T raised to the power of A times -2, and we have -2A. Then here we have L raised to the power of B, at the same time M raised to the power over M raised to the power of C. So now you can see we have some terms that are the same. We have M, 2M, at the same time we have 2L, even we have 1T. So what did I need to do? I can just what? I can just pick the values and substitute, make a simple substitutions. That is, since I have 2L, I can just pick one, add their power together, just like addition law. So here I can have LT raised to the power of -1 is equal to, now this is M, this is M. So I pick one out. So remember the addition law. The moment you pick one, you can add their power together. The power of this one is A, and the power of this one is C. That means I can have A plus C. We pick one and we sum the power together. So this is T, this is L also, this is L. I pick one. So the power of the first L is A, and the power of the second L is B. So that means that we have A plus B. So now for T is only 1. Then I just pick one. That's a T raised to the power of -2A. I hope you are getting it right. Now the next thing is to compare the two sides. What we have on the right hand side together with the one we have at the left hand side. But the problem here is, you can see I have L. I can compare L to L, right? I can compare T to T. But can we compare M to M? Do we have anything M here? No, fine. But you don't need to confuse. Though it's very simple. Just put M here. That's M raised to the power over 0. M raised to the power of 0 is 1. If I multiply 1 by this, it's still going to remain what we have initially. It doesn't change anything here. So even assuming it is still that missing, just put T to the power of 0 so that you can compare the three sides together. So now, by comparison, M for M, at the same time, L for L as well, T for T. So now let's first pick M here. That's that we have M raised to the power of 0 is equal to M raised to the power over A plus C. That's the first one. Then for L, L raised to the power of 1 is equal to L raised to the power of A plus B. The third one, now you can have T raised to the power of -1 is equal to T raised to the power of -2A. We are just comparing the coefficient of M one after the other. So now, let's look at let's see the next step so that we know what is needful. Now, so if M cancel M here, M can cancel, just like I said earlier, since the bases are the same, that what that we have here is 0 is equal to A plus C. That's the first one, right? So if L2 cancel L here, I can have A plus B is equal to 1, right? So at the same time, if T cancel T also as well, I can have -1 is equal to -2A. So we have gotten out the three values. So the first one I have A plus C, let me put it here, A plus C is equal to 0. That's the first one. Let's call it equation 1. So the second one I have is A plus B is equal to 1 as well. Let's call it equation 2. Then the last one I have is -2A is equal to -1. Let's call that one as equation 3. It's not simultaneous. It depends, since the unknowns can be substituted to find the other values. Now, I want to find the value of A. You can see if you look at the first equation, we have two unknowns there. If you look at the second one, we have two unknowns. If you have the third one, we have just one unknown. Now, in this one, I can find my A. So the values are by -2 by -2 here. Since the third equation contains just one unknown, So that means here I can have my A to be 1 over 2, right? You get that? Because if you look at this, I have two unknowns. If you look at this, I have two unknowns. But if you look at this one, I have just one unknown. I can quickly find A there. So the values have a minus 2 there. So if minus cancel minus, of course, I will have A to be 1 over 2. So if you look at this one, I can find C now. It's straightforward, and I can also find B as well. In the first equations, what do we have in the first equation? In the first equation, what we have there is A plus C is equal to 0. So what do we get for A now? Our A is 1 over 2. That means I can have 1 over 2 plus C is equal to 0, right? If I collect like times, then we have C is equal to minus 1 all over 2. So of course, I've gotten C. It remains for me to find the value of what? The value of B. So I have, in the second equation, I have A plus B is equal to 1. So now my A is 1 over 2. I can have 1 over 2 plus B is equal to 1. You know, this one is just like a simple simultaneous equation, simple equation. If I collect like times, I can have B is equal to 1 minus 1 over 2, meaning B is equal to 1 all over 2, right? So now we have gotten all the three values. A is equal to 1 over 2. B is equal to 1 over 2. At the same time, we also have C to be minus 1 over 2. So let's go to the first equation that we are given there. Here. So in the equations, what we are given there is V is equal to K F raised to power of A, L raised to power of B, and M raised to power of C. So now I can make a simple substitutions to obtain what I was asked to show. So now I can have this one to be V is equal to K F raised to power. You know, my A is half now. That is half. Our B is also half. This is 1 over 2. Then M C is minus 1 all over 2, right? Fine. So now, you know, under indices, if I have A raised to the power of 1 over 2 is nothing but square root of A. So now I can just quickly apply the values formula here. If I do that here, I can have this one to be what? You can see that it's very simple and straightforward. I can have this one to be VK root of F multiplied by root of L multiplied by, but you can see this one have a negative, right? You remember? Ah, good. So that one can be root of M because that one contains a negative sign. So now, you know, under the sort, if I have root of A times root of B, this is nothing but root of AB, since the two of them are inside root. So that's what I'm trying to do here now. I can have this one to be V is equal to root of F times root of FL. That means I can have root of FL over root of M. Of course, I can still change this one. Since they all have root, I can have V to be equal to K square root of FL all over M. So hence the problem is solved. That's what we are asked to prove. So that means V is equal to K all root over FL over M. You can see it's very simple. There's nothing to be panic here. The first thing you need to do, just know what each letter given there, each variable given to you in the problem, know what each of them represented. After that, then you call that what's the dimension of the first one, of the second one, or of the third one. So let me solve one more so that you can conclude this area. Let me just short it so that it will save time. Okay, let me just derive equations. Let's just derive equations. Let me just say given that T is equal to M raised to the power of alpha, L raised to the power of beta, and G raised to the power of gamma. You say find alpha, beta, and gamma. Given that T is a period, which is time, M is mass, L is, okay, let me write it. Given that T is time, the period of the oscillations or something given to us like that. Maybe they said M is mass, L is length, and G is acceleration. So let's say we are given something like that. So it's also simple and straightforward. So just follow it, the same process, the same logic, the same method. Now remember, T is T under dimensions, right? Fine. M is also M. You remember that? L is also L. But G, do we have a dimension for G? Yeah, good, because G is nothing but acceleration due to gravity, and G is A, I will know this is nothing but LT raised to the power over minus 2. That means the only thing I need to change here is G, right? Yeah, fine. So there I can have T is equal to M raised to the power of alpha, L raised to the power of beta. Then I will change my G, L raised to the power of minus 2 over gamma. So please don't forget, you can put them in form of a closed bracket. It's still the same thing. Don't be confused about that. So even this, I can just put it like that. So just to make it easier, that's why I'm just trying to ignore them. So now, if I open the bracket of this, I can have T is equal to M raised to the power of alpha, L raised to the power of beta. Open this, that means that we have L raised to the power of this. No, this is 1. 1 times gamma, we have 1 gamma, and 1 gamma is the same thing as gamma. T raised to the power of minus 2 times gamma, we have minus 2 gamma. So let's look at the one that are the same. Do we have anyone that are the same at the right-hand side? Yes, of course, we have L. We can pick one. M raised to the power of alpha, then L raised to the power of beta plus gamma, T raised to the power of minus 2 gamma. So now the problem here is you can only compare T for T. You can see there is no M, at the same time there is no L. So you don't need to be perplexed about that. Just take them one after the other. Recall that under the law of indices, anything raised to the power of 0 is 1. Just be picking them one after the other. So here I can have this one can be T. T remains as it is because it doesn't change anything here. There I can have M raised to the power of 0 and L raised to the power of 0 as well. You know, M raised to the power of 0 is 1. L raised to the power of 0 is also 1. So if I multiply 1 times T, I will still have T, right? Good. So M raised to the power of alpha, L raised to the power of beta plus gamma, and T raised to the power of minus 2 gamma. So what is the next step? Is to compare what we have at the right hand side together with the one that we have at the left hand side. So M for M, L for L, at the same time T for T. So the moment we do that, so once you do that, so meaning we have M raised to the power of 0 is equal to M raised to the power of alpha for the first one. M raised to the power of 0 is equal to M raised to the power of alpha. So for the second one, now we have L raised to the power of 0 is equal to L raised to the power of beta plus gamma. That's for the second one. Then for the third one, I can have T raised to the power of 1 is equal to T raised to the power of minus 2 gamma. You can see I've already formulated all the three. So in the first one, if M cancels M here, so luckily our alpha is equal to 0 because it only contains one unknown. In the second one, if the L cancel here, just like indices, we are equating them, meaning beta plus gamma is equal to 0. Now here I cannot find any value because here it has 2 unknown. So the third one, if this cancel this, that means that we have minus 2 gamma equal to 1. Of course, I can find the value of gamma because here it has just one unknown. So divide by minus 2 by minus 2, gamma is equal to minus 1 all over 2. So since I've gotten the value of my gamma, of course, I can just make a simple substitution to find the value of beta. What we have there is a beta plus gamma is equal to 0. So what do we have for gamma here? Our gamma is what? Yeah, minus 1 over 2, and we have beta plus minus 1 over 2 is equal to 0. You know, if plus and minus follow each other, it's going to become a negative. So here we have beta minus 1 over 2 is equal to 0. So if I correct the like term, this is minus. When the minus comes, it's going to become plus, right? Yeah, nice. That means that we have beta is equal to 1 all over 2. So meaning here, A is equal to, alpha is equal to 0. Alpha is equal to 0. Beta is equal to 1 all over 2. And gamma is equal to minus 1 all over 2. So that's all of what we have for the unit measurement and dimension. So you can see if you check materials, we are going to have many or additional example as well, many exercises. So please don't forget to like our videos, try to subscribe and also share so that other people too can benefit from this gorgeous tutorial we are doing. So this is Made Easy Academia. So please don't forget to like our videos as I mentioned earlier. So thanks for watching. So watch out for the next video to come for this general physics.